Okay, so let's go through a typical kind of problem that you might be asked in this section. Let's say you're told something like the following. Let tangent of theta equals 2/3. What are the values of the sine and cosine of the angle theta? Well, we do have to remember that what we're telling you right here is that we have a right triangle whose ratio of opposite to hypotenuse side is 2 to 3. Now, very often people have trouble just reasoning this out. There are identities that we can use to help us find these things, but usually a picture is worth 1,000 words. So let's go ahead and let's just look at a picture right here of this expression. What do we mean? Well, if we were to make a right triangle, we would put 2 in the opposite side and 3 in the adjacent side. So what does that make our hypotenuse? We would want to know that to get the other ratios of our trigonometric functions. Well, by the Pythagorean theorem, of course, we would just simply apply it right here. And if we substitute it in the correct values, a squared plus b squared equals c squared, we make the substitutions, take the square of 2, take the square of 3, and we get the square of c, whatever it is, that's our hypotenuse. So let's see, 4 and 9 add up to give us 13. That is the square of the hypotenuse, but we actually have to take the square root, and we're only going to go with the positive. We don't have negative hypotenuses in our world. So we're going to say square root of 13 is the length of our hypotenuse. And now finding sine and cosine is pretty easy. We will say that the sine of the angle theta, whatever the angle theta is, we don't have to know it, is going to be the ratio of sine 2 over the square root of 13 in this particular case. Or when we rationalize the denominator, we would write 2 times the square root of 13 over 13. How about the cosine? Well, similar deal, right? Cosine of the angle theta is our adjacent over hypotenuse, 3 over the square root of 13. And so we would rationalize the denominator in this fraction. We would find 3 times the square root of 13 over 13 as its value. And we leave it in this form. We're not so much interested in the decimal form, at least as far as we're concerned. So we would want to be able to rewrite it this way. Okay, easy enough. But the other question we would want to ask is necessarily, well, all right, in this case, we were given 2 sides. What if we are given 2 sides? What if we're only given 1 side? Well, if we have enough information to create our trigonometric functions, then we would certainly want to know that. And so, a typical kind of application might be something like this. All right, we're told that we have a right triangle that contains 52 degrees this time and has an adjacent side of 3.2. How could we use this to find the length of our opposite side? Well, we would certainly be able to do that because whenever we get our ratios, whenever we tap these numbers into a calculator, here's what's happening. If I'm interested in this opposite side, I would need to use the ratio for opposite to hypotenuse, or opposite to adjacent, right? Because I'm given my adjacent side, and so if I'm interested in my opposite side, I need that ratio. And I know that the ratio that goes with it is the one that tells me that the tangent of the angle, whatever it is going to be equal to the ratio of the opposite side to the adjacent side. Well, we know one of those lengths already, right? We know that if we take the tangent of 52 degrees, whatever its value is, and take our unknown value, divide it by the adjacent side, which we do know, we can solve for that side pretty easily.